All right, welcome to the second FSL3D webcast. I'm Nathan Rowe. I'm a mathematician and software engineer, and this is Andrew Jerry. Andrew.
Yep. What's going on, guys? Good to see everybody again. We're going to be answering some questions at the beginning of this webinar, and we're going to follow that Q&A session. Nathan's going to go through and do a demo / how-to explaining supports. So he's got a bunch of models, and he's going to go through and sort of explain how the support algorithm works, you know, what areas of models you want to be supporting, times when you want to supplement the automatic support algorithm, and then are you going to touch on a couple of the advanced features at all, or?
Yeah, and I'll also show you some new support features that are coming out with the automatic support algorithm.
So I think we might have an error right now. Stand by, folks. Gotta hydrate this thing.
Sound is working just fine.
Yeah,
I think that it's just an error in my browser, so I don't think that it's a problem with the feed.
Let's see. Oh, good. Yeah.
So muted. Okay.
Awesome. Yeah, and so Nathan will take you through, you know, the basics of supports, times when you want to add manual supports, editing supports, talk about some stuff that's coming in releases, give people a better idea, because what we're seeing is that some people are new to 3D printing, and they, you know, being able to go through the supports, because this is pretty different from FDM and what people are used to, is something that we're seeing a lot of people.
Yep. All right. I think that this time, instead of going through a demo first and then answering questions, we're going to answer a bunch of the questions first, and then I'll come back to questions that you've asked during the show. So on the Google Groups forums that we have, we've got a few questions. Looks like 6 or 7 people asked questions. So the first one is from Master Shokin.
Yeah. And Master Shokin is asking about, his first question is, wintertime printing tips. Do we put the heat on full blast to get the correct operating temp? The second question is the laser making multiple passes on models from the store and one pass on native models? So the first one, for the operating temperature, we've heard of a few people that are keeping their printers in a garage or somewhere else that's not very temperature controlled. The resin itself doesn't have any particular requirements other than not being exposed to very high or very low temperatures for extended periods of time. But otherwise, if the temperature dips below, 50 degrees Fahrenheit or above 100 for a short period of time, that shouldn't have any functionality effect. But for optimal printing, you are going to want to keep the printer around 70 degrees. I think we said 65 to 75 or something like that.
That's a pretty good range, or 65 to 78 or something.
Yeah, and we've put it in a very highly air-conditioned server room and tested it down into the low 60s. But really, once you get below about 60 degrees, what you'll actually start to see is that the viscosity of the resin is somewhat sensitive to temperature, and the increase in viscosity will cause potentially suction issues. So if you get down below about 50 degrees, what's going to end up happening is that increase in viscosity is going to make the first few layers of your part, or if you have a large surface area in your part, it's going to make the release more difficult from a mechanical standpoint. It'll put more tension strain on the parts. So again, during the winter, it's nice to keep the printer inside. The other thing is that big temperature changes can cause condensation, and that's another thing you want to avoid, because there are a lot of glass optical surfaces. So if you get condensation on those, it can interfere with the laser beam.
Right. So you can have prints fail if you're running at low enough of a temperature. So try to, the optimal range is 65 to mid to high 70s. So try and keep it in there. His next question was about the laser making multiple passes when things are printed from the model store, but not when we send them from Retina Create. And that is true, because a lot of the models uploaded to the model store uploaded a while ago with settings that worked pretty good. We have later found better settings, and those are the settings that we use in Retina Create. And one of the main advantages to the new settings is it increases the life of the PDMS layer. And so the old one, the multiple passes it harmed the PDMS layer a little bit quicker, but it's not a big deal, so we haven't bothered to re-upload models yet. But yeah, that's true. It is taking multiple. It is doing a slightly different lasing algorithm.
And our next question is from Lauren Shearer, who asks, what is the best support option for printers ordered by lower tier international backers? And then a further follow-up about rates of shipping damage. The best support option for international backers, regardless of tier, the support is the same. We aren't covering shipping for people in the U.S. or internationally. What we are, able to do for support is we're working to set up European distributors and distributors in other countries. That is on a longer timeline, but the plan is to have people that you'll be able to ship your printer to inexpensively for repairs, or that you'll be able to get parts from and perform, assisted repairs with some guidance from support on your own.
Okay. So Rick Sequoia is asking about. He says that after 10 prints, his VAT isn't working anymore, and had used alcohol to clean it. And is that a problem, or what? How should you clean VATs, etc.? And so the lifetime of a VAT varies dramatically based on how big of prints you do and how much area each print takes. And so 10 prints may have been a really quick VAT or a slow VAT, and you can also print at different locations on the VAT to extend the life that way. We here at FSL3D always use alcohol to clean our VATs, and from what we've read on the forums, it's possible that is decreasing the lifespan of our VATs, but we haven't really tested it. So
there seems to be conflicting information.
Yeah,
because we've heard some people have contacted Dow Corning and heard that alcohol is a no-no.
Mm-hmm.
We spoke to a representative at Dow, and they said that PDMS is designed to withstand much harsher solvents than 99% IPA. So it would seem that the jury's out. The place where we're sort of doing the most heavy testing, aside from our lab machines, is in production when we do the pre-print testing. Those VATs get reused a lot. The typical procedure that I like to follow, and what I've been telling people in support, is that scraping the VAT, scraping the resin out, works fine. And typically you only want to clean it out with alcohol if you're going to be leaving it sit for a long time. So I don't like to leave resin sit in the VAT. What I'll do between prints is, if I'm going to leave the VAT sit overnight or more than 12 hours, I'll empty it out and I'll make sure that I filter it, and then I'll store it in the bottle or another opaque polyethylene or polypropylene container. And if I need to store the VAT for more than a few days, what I'll then do is I'll take the alcohol, put some gloves on, swish the alcohol, make sure the VAT's very clean, and then dry it out. And that seems to work pretty well. And one thing that I recommend to people is that aggressive filtration of your resin is never going to hurt. But the procedures in the manual and the procedures that we have on our wiki, FSL3D.wikispaces.com. I got that right, yeah?
I think so.
Yeah. The procedures on the wiki are always being updated, based on what we're seeing here and what we're seeing from customers in the field, if people are reporting particular issues with their VATs. But the overall consensus from our experience and from a lot of people is that washing the VATs with alcohol, as long as you're keeping it, mostly the PDMS layer, doesn't seem to be too big of an issue.
So another thing that I guess now is a good time to bring up is that we have new VATs that we're working on in the lab, and they seem to be great as far as how much longer they last, as well as how quickly you can print on them, because the release mechanism, or the release is easier on the prints. So for now, we're calling these the super VATs. And it seems like you can print the lift and lower time, we can cut by a factor of 3 to 10, and the lays time is the same. And we have not yet had a single VAT cloud or show an effect similar to clouding, so they seem to last a long time. We're not sure how many prints exactly, but looks to be maybe hundreds.
Yeah, the super VATs should last more or less indefinitely. Is what our current estimates are right now, and we'll be hopefully getting those into production very, very soon, so that people can print with them.
Yeah, we're really excited about that. It makes things a lot easier, but they're not quite ready yet. We need to figure out how to best package the new materials together. but those are definitely coming. So let's see. The next question is about dimensional accuracy in X, Y, and Z, and compensating for resin shrink, especially in the XY plane. And also the Linux software release, right?
Yeah. So right now we'll address the Linux release first. There's not really a hard timeline set for Linux. Basically, the timeline for Linux support is going to be after the Windows and Mac versions are stable. So certainly not before the end of the year. Those of you who downloaded the Mac version have seen that it's very nice. There's still a lot of ways to go in terms of getting the automatic support and a lot of these other advanced features up and running. So that's a longer term goal, but it is in the development pipeline. And as for responding to the dimensional accuracy, right now we have some scaling functions built in. We realize that everyone, I wouldn't say everyone, but a large number of our customers, a large number of you folks are out there buying this printer specifically for, the really nice surfaces and high detail and high accuracy. So that's one that we're working on. The shrinkage of the resin isn't purely it's not a very simple thing. There's second and third order effects. It's very geometry dependent, so it requires a lot of testing to compensate for different geometry effects. So what we're releasing in the next software version, we have a few updates that'll help compensate for the shrink. We have a few things that we're working on, and then it's going to be sort of an ongoing target as the platform gets more mature, on Windows and Mac. What we'll be doing is devoting more and more of our time to specific cases. So if anyone has questions in the meantime, they can obviously direct them to support, and we can use, you can use support as a sanity check to make sure that what you're seeing is, a fixable issue, or if it's something else that might be going wrong. But typically the shrink is fairly low. So if something seems really out of whack, just contact our support team.
Yeah, okay. So Esteban wants tips for printing models that have a hollow structure. And residual resin that's stuck on the models. So we have used, and a lot of people in the forums seem to use, ultrasonic cleaners to help clean models. Usually it's enough to just let the model soak in 99% IPA for about I don't know, we usually leave them in for about an hour or so. Leaving it in longer will sometimes make the model a little bit soft, but it tends to not have any damaging. It doesn't damage the surface quality, so you can err on the side of leaving it in longer.
And it helps to agitate your alcohol if at all possible, to be gently swirling it around. The ultrasonic cleaning, we abandoned that because we didn't see good results. A few people have reported good results with it. I would caution people that alcohol, especially 99% IPA, is a volatile material. You need to be taking the proper safety precautions if you're going to be using an ultrasonic cleaner. So what we recommend is a container that you can cover. For big models, we just use a 5-gallon paint bucket. For smaller ones, we're using Tupperware containers. But we recommend something that you can put a top on. That way the IPA doesn't evaporate. And if you can just shake it gently for the duration that you have the model in there, that helps agitate the resin and draw it away from the surface of your prints.
And if you're trying to print a model that's already hollowed, it's hollowed before it enters into our software. That can be difficult. The supports, hollow things with thin walls often need supports along them, and if you get to walls that are thinner than about a millimeter, they're prone to fail if they're too tall. And when the hollow part loops up, if the top is unsupported, you'll often get failures there. So we recommend not hollowing models before you enter it into our software, because our software has a special algorithm for when it hollows models. It also produces a support structure inside the model, a lattice of very thin parts, and it does use up some resin in the center of the model, so you don't save as much resin, but it doesn't use that much. It uses up about 10%, I think, or maybe 15% of the hollowed out space. So you still save a lot of material from hollowing, and you also will often get better surface quality from hollowed models than from solid models. So I'm not sure if that's the question you were asking, but hopefully I addressed that. Cleaning internal surfaces that can't be reached, if you just have to soak them longer in IPA, or you know, we covered using potentially using ultrasonic cleaners and things like that. So Master Shogun has another question. Can you give us a quick written breakdown?
We'll be covering some of those features when we get to the actual demo portion of the webinar.
Oh yeah, that's true. Yeah, I'll go through a bunch of the features for supports and what they do. Some of them are not named very intuitively. That's a good point. So we might we would consider renaming things to be a bit more intuitive, and we do write tooltips. So I'll point out where that is.
I read that new message.
Sure.
Naman Renfro, we addressed a little bit earlier, but there just seems to be conflicting information even from Dow Corning itself. Our sales rep at Dow said that alcohol should not have any effect on PDMS, that it's designed to be resistant to a variety of solvents. It seems that other people on the forums have heard differing information, even from the same horse's mouth. So it seems to be up in the air. You know, we're not really sure what to do about that, but we make the recommendations based on what we see here, and what we have running is about 15 machines in the lab that are running, you know, 24 hours a day, 7 days a week, and running long, you know, 48, 72-hour prints over the weekend. And then what we have in our production area, where every machine has to pass a print test before it ships out. So if things change, and you know, things might change, that's something that we'll definitely update you on. But for now, we do recommend alcohol for thoroughly cleaning the vat, but typically we're not using alcohol between every print. We're cleaning the vat out, you know, we're scraping it clean to make sure there's no residue, and then filtering that resin and then returning it to the vat. And I would say that we probably clean the vats, you know, if we're going to store them, we clean them, or we're going to be cleaning them, you know, maybe every 10 prints or something. But typically we're not using IPA between every single print. That would be kind of a pain in terms of just cleaning the vats.
So Nolan also asks about response times from support. I think they try to answer things the day they receive them. Is that?
Yeah, one of our support guys is out, and the support team handles the laser support too. So typically within 24 hours, some things can slip through the cracks and might take a little bit longer.
Right. If you go a few days without getting a response from support, ask them again. Sometimes things do slip through the cracks.
Yeah, and you know, one of the nice things about FSL3D is that we do have a phone support line. Mm-hmm. So if you aren't getting a response or something urgent, you can definitely call in. That's a good way, and you'll be able to set up an appointment with support too. That's one thing that we like to do, is set appointments so that we have a schedule throughout the day and sort of a guaranteed time to follow up with people.
Okay, so now we're going to switch over to the questions that came through YouTube. Do we use a resin especially dedicated to our machine? Yeah. The machine and resin are very closely tied. So depending on the laser strength and the vat properties and the size of the build head and the amount of tension we expect and stuff like that, all of the properties that the machine run with will be specific to our resin. And if you change resin, higher viscosity might cause the motor to skip, or a less sensitive resin may fail to cure and things like that. So if you use other people's resins, it's not likely to work, and also I believe it voids your warranty. So we recommend that you only use our resins in our machine, and we try to keep the prices down pretty low, lower than all the other machines' dedicated resin prices.
Yeah. And it seems like there's one more question from Kirk Davis in the YouTube chat regarding the PCB etching. Kirk, yeah, you're right. It is a lower priority than the software stability. It is something we want to keep working on. For the time being, if you can export your traces in some sort of 3D file format and get them into an STL, all we did to make that is we took a double-sided a clad circuit board, double-sided taped it to the aluminum, and then printed. And I think that we only printed about not even 10 layers at 100 micron. We printed maybe, 3 or 5 layers. It was pretty thin, and it will adhere to the copper and come out. The one thing that you'll see in that situation is that you'll need to essentially, once you put that copper clad board onto your printer, you'll need to rehome the machine. But yeah, you could do it right now if you can get a 3D model of your traces. Otherwise, that's a forthcoming feature.
Did you read any of these? Are you several people?
These ones a little bit lower.
The PDMS layers filling soon. What is our typical vat life in the assembly room?
We're typically printing mini rooks in a grid pattern on that, so it's not necessarily representative of what other people are seeing.
Okay.
But it is repeated printing over and over in the same area, and I think that I'll get through maybe like 6 to 10 mini rook prints in a single area before we start to see degradation.
And they're
about an inch and a half tall.
Okay,
inch and a half tall.
200 to 300 layers. So it's about 2,000 or 3,000 layers.
Yeah, and that's we won't pull those vats till we start to see things fail. But I would say usually at least somewhere on the order of close to 10 cycles.
Right.
The vats can take a fair bit of abuse.
And as we said, these next vats that we're currently testing and coming up with a final design for do last a lot longer. We don't even know how long because they haven't failed yet. So.
And then it looks like the last question is the colored resin. The colored resin is out at our bottling facility. I don't know if we'll have it quite by the end of this month. It takes them about a week or so because they are pretty busy with other people that they're bottling things for. But all the components are there, and now we're just waiting for it to be mixed and bottled and then shipped back to us so that we can distribute it to you guys.
Right.
I think we'll have quite a few colors because we've been working pretty hard in the lab. You can see we've got a very nice white resin. We've been printing some fun stuff.
Yeah.
That turbine is pretty cool.
Yeah, it is. I'm excited for the finished product. But the white resin is supposed to start shipping as early as next week. 2 weeks. As early as 2 weeks from now, you should be able to purchase white resin. And then the rest of the colors will be coming out, over time. Hopefully sooner rather than later. What's next?
I think that's it. Any other questions, folks, before we start to move into the second half?
Yeah, and you can continue to ask questions during the second half. Andrew is going to take off and get back to work while I walk through some support situations and how to properly support models. So questions about software especially are ones that I'll have an easy time answering.
Yeah, that's it. So, folks, I'm going to leave you in Nathan's very capable hands. He's going to go through and do a demo now of the support functions, the basics, and then a few advanced topics, things that you'll see. We print a wide variety of models here. Some of them are fairly complex. So what kind of things you're going to see in terms of, what are some problem areas, what are times when you want to supplement with manual supports, and also a few new and interesting things that we're working on with our algorithms. And so with that, I am checking out, and have fun, buddy.
Andrew. Okay. All right. I'm going to switch from a camera staring at me to a camera looking at my screen. Let's see if. All right, hopefully you guys can see this. All right, so what I'm going to do is just add a couple models and to talk through how to support them and how to support it with minimal supports, how to best support it, how to orient the model, etc. So let's see. I'll start off with something fairly simple. This is a chess piece, a pawn. And then nothing juts out terribly much. This here juts out horizontally enough that with an FDM printer it would probably fail there because the angle's too steep. It would produce a lot of stringy material that sticks out here. But in an SLA printer, one of the main advantages is I mean, probably the main advantage is the high resolution, but another great advantage is that you can have these horizontal juts for a little bit and it's okay. So with a model like this, you could potentially print it directly on the build plate as is. If you do that, this portion of the model right here will have a little bit of variation in its height, and that's because the build plate when it's lowered is not lowered to like micron accuracy. There can be a little bit of a gap, or it can be pressed into the PDMS layer, depending on how you set the motor homing on your machine. So if you print things directly on the build plate, that's fine, but be aware that your Z accuracy will be off by as much as maybe 0.5 millimeter, depending on your motor homing. So right now I've got the supports in a wonky mode. No, I guess that's not true. So if you want to support this model so that it is accurate in the Z direction, if you just do the standard supports, you get something that samples the bottom pretty well and hits all the places. There are some gaps around the edge here that are probably fine, but you may want to add some supports there. On this side it looks okay, and in the center it's sampled pretty finely. So the reason that there are so many supports on the bottom are because with big flat areas like this, you need to have the supports tightly packed, or else there will be some during the printing, the weight of the resin on the back of the freshly cured layer will push it down and end up warping material, and you get little bubbles of uncured resin sometimes if you have large enough gaps. So the supports need to be fairly close together, especially for flat layers. So if I wanted to print this, I would probably add a support here. You can add supports by holding Control, and here, and now it seems pretty safe. This, like I said, this area over here is it's definitely fine. It doesn't need more supports. You may get a slight amount of pull upwards. So if you were to actually take somehow be able to measure the height from here to here with some sort of tool, it might be off by a couple hundred microns because of the suction force during the pull when it's unsupported on these horizontal things. But it'll be a very small error. So another way you might want to print this, because downward facing surfaces never get the best quality, with an object like this, you might want to tilt it like something like this, maybe 30 degrees. Or you can ask the software what the optimal orientation is, and some limitations to the optimal orientation are that it doesn't know which surface of the model is most important that you don't want to have supports on. So it found that by orienting the model like this, it had the fewest downward facing surfaces. That's all that the optimal orientation is doing right now. And that's not really what you want, because in this case, the part that you want to have the nicest surface finish is the top part. The bottom doesn't really matter. It's going to be facing down. People won't see it. So ideally, you'd like all or most of your supports to be on the bottom instead of on the top. So flipping it upside down doesn't really work for you in this case, but it would if you flip it this way and then support it. It would have the least chance of failing. So what the orientation that I would recommend might be an orientation like this, and now you can see that this part of the pawn actually dips downward. So if you go through the slicing, there's a part right here. Let's see. There's a part right here where a floating, when the model is printing upside down, this will appear floating, separate from the model, and it only exists for it's only floating for one slice, but then it's barely attached for another slice, and then it's pretty securely attached. So it probably wouldn't fail, but it would. There's a chance it would fail to print because it's unattached and it would sort of have a cascading failure. And there's a chance that if it doesn't fail to print, it will probably be dimensionally inaccurate there, and so you'll see that it'll have flattened out in this region instead of keeping its shape. So the software will notice that that's an unsupported region, and when we generate supports, it'll hopefully automatically have added a support right there. Yeah, okay, so it creates one support right there at that lowest point and a couple supports over here, and then it supports this base. And now these supports are a little bit further apart, although not much further apart, and the surface between them, since it's angled, will be much cleaner, and you don't have the risk of that the weight of the resin causing drooping. So one thing that I wanted to show you guys is one of the things we've been working on for the next release, hopefully the next release, but we'll see if we get it done in time, is I have a new way of calculating supports where it pools nearby supports into a common base that's thicker, and it ends up saving resin. So in this job we use 11.9 milliliters with the standard supports, and if I use these tree supports, it pools a few of these into a common base, into a common trunk, and it saves a little bit of resin. It's 11.3, so we saved 0.6 milliliters of resin in this model, which is not impressive. In other models, it can save as much as 30% of the support material. So I don't know how much of this is support and how much of it is the model itself. It's a work in progress. We're constantly making improvements. So there used to be supports up here, and what happened right now in this example is this support tried to print and connect to the tree, but then it got too close to the model here, and so it just deleted the support instead of reverting to a vertical drop down support. So we're going to be changing a couple features so that doesn't happen, and it'll continue to support those points. So I'm excited about the trees. I've got we've only done 2 prints with support trees so far, so it's a very new feature that's fairly untested, but it saves a lot of resin, and it seems to be just as structurally intense. So as I'm talking about these things, I hope that you sort of get an intuitive feel for what needs to be supported with an SLA printer and what doesn't. So at the last one I talked, there was that little bit in the pond, there was that small jut outward that I said did not need to be supported, even though it shot out horizontally for a little bit. In this tree frog, we've got this long body of the tree frog that is a fairly shallow angle sloping outward like this. The tree frog can be printed as is directly on the build plate. It doesn't need any support material at all with our printer. Even though this overhangs and connects and things like that, there's nothing. If I do the model analysis, highlight unsupported features, I believe nothing gets highlighted red. There's some yellow to indicate downward facing surfaces, which may have reduced surface quality. But there's no red, there's no unsupported surfaces. So the tree frog can print exactly as is. But if you scale the tree frog up, it may there's the hands and the belly are what's supporting this. So there's some angled angled stresses during the printing process. So if we generate supports, we try to put supports all over the model just to decrease the stress during printing and reduce the chance of print failure. So if I size this tree frog up and add supports, I'm still in tree support mode, so that's what you'll see. It takes a little bit longer to compute because there's a lot more triangles in this model, and it's also larger. But here we go. You can see the trees connecting all over the model, and it's supporting especially up the front of the frog where there would be large tensions. So it does a pretty good job, but if anything, it over supports. So if you want to print a tree frog, what I would suggest doing in most cases is to not use our supports, and just look at the places where it overhangs by quite a bit, and you can just add a couple supports without even elevating the model. So you can just add a couple supports along the frog's underside, and then it should print fine. I mean, it would probably print fine even without these supports, but they can help. And with a model this large, it's always helpful to shell the model to make it hollow. Once the model is shelled, it doesn't show it in the viewer right now. In the Mac viewer or the multi-platform viewer, it'll be sort of Retina Create 2.0. It will replace Windows as well, so all of them will be this new framework. So in this one, you currently can't see that it's hollow until you go into shell mode or into slice mode, and then you can see the hollow slices, and there's a lattice of supports inside, so that when the model gets to the top and there's the flat part where it closes, it doesn't fail. So right here, without that lattice of supports, this part would be very difficult to print, and it could rip the model apart and it sort of have a frog with an exploded head, except that we do this lattice of supports inside that make it a lot stronger. Okay, so I'll go through a couple other models. Let's I had some prepared. This one's interesting. So this is supposed to be a pulley used in print. You print this to use in some mechanical component. So it needs to be smooth along this outside, and it needs to be accurate on the inside to connect to the bearings or whatever it's connecting to. So with that in mind, the place where you want the least supports is probably this tube structure, and you don't care as much about these sides. So what I would do with this model is rotate it 90 degrees, so that it's oriented like this. And now you could print it directly on the build plate, depending on whether or not if you care about the Z accuracy, if you want this height to be dead accurate, if you want to, sorry, I was just checking a message from a colleague. If you want this height to be dead accurate, then you'll need to support the model and raise it up. And in that case, you'll probably also want to angle it so that the downward facing surfaces are minimalized. So if you print it directly like this, you'll get nice surfaces everywhere. This lip overhang is fine. It's only about 1 millimeter, maybe 2, and that's fine. There may be an ever so slight warp. So if that's a problem, then you'd also want to rotate like this. And now once you've rotated the model like this, you'll need some supports along here. You won't necessarily need supports along here. So the automatic support generator will create supports there, but you can just delete them. And you need a support here at the base. So we can either elevate the model and then manually support it, or we can do automatic supports. And for this model, the trees are still sort of a work in progress, and so I know that the tree trunks right now are not deletable, only the tree branches, and that's going to be done before we release. And there's going to be a trunk right here if I did it with trees, so I've switched. So this is what the automatic supports generate, and you can see that this bottom part here is supported, which is the critical part to support, and the bottom part right here is supported. And the rest of these supports are probably unnecessary. They help increase the likelihood of a success, especially having a support here. If you have one support here, then when you're printing a layer around here, instead of it pulling the model up and around like that during the peeling process, which creates extra strain on the model, it is stabilized by this support. So it can sort of channel the peeling forces straight down into the build plate. So I would, if you hold down Shift, or is it Alt? There's a way to delete multiple. I actually can't remember right now, but you can go through and delete the supports that you don't think you need. So this support right here is the crucial one, and I would probably leave these two supports as well. And once that's done, you have a well supported model, and this will print fine. And this, because it's angled at what angle is that? About 32.5 degrees. It'll be fairly accurate. It won't dip. And the bottommost part and this overhanging part are supported. So if we do highlight unsupported features, it'll do an analysis, and none of the model is red. I'm not sure why it all came out yellow. That's interesting. Okay, so next I want to use this is one of our favorite test models because it has a lot of overhangs and things like that when creating support generation software. So I'm going to talk about what some of the support options do. So the base height refers to, let's support this so that you can see. The base height refers to the height of these little attachment points on the build plate, and it's 2 is in millimeters, so it's set to 2 millimeters right now. The cone length is at the tip of these supports. The cone starts around here and extends into the model, and so the cone is 2 millimeters long. Its height from this. Let me zoom in. From here up to the invisible point inside the model is 2 millimeters. The corner divisions is here where the cone curves to point straight down. That's how many corners it creates. So this joint can be made more circular by increasing that number or less. So it's not a very useful thing to be able to alter. For each of these, you can see if you click them. For each of these, if you click them, you can see that the tooltip down here gives you a little bit of a better explanation, and so hopefully that's helpful in case you forget some of these things. So the crossbeam min height is the height of a support. So crossbeams are not generated unless so this is one of the new features that will be in the next release, by the way. But the crossbeams are these support beams connecting other support beams together. They have a height, a drop-down height from the model, a distance from the model, and also there's a minimum height that the beam must be before crossbeam is made. And so this beam is not connected with cross beams because the height of this beam is less than that 15 millimeters. So if you increase this to 20, or I typed 25 and said 20, let's do 25, and I support again, you'll see that some of these cross beams will have been removed here, but they'll still exist up here. So these beams are no longer considered tall enough to generate cross beams. And then there's also a crossbeam, a max crossbeam length, so it won't create crossbeams. It won't create crossbeams that are between supports more than this far apart. That's 11 millimeters. Everything is in millimeters. And the crossbeam pullback is, if I return this to its default of 15 and increase this crossbeam pullback to 5, that's how far from along the support the crossbeam is drawn. So the crossbeams were drawn at about this height, 2.5 millimeters down from the joint, and now it'll be 5 millimeters down from the joint, and so it'll be down lowered a little bit more. So let's see what that looks like. Oh, I was just told that the options menu doesn't pop up in my screencast. I think there's a way for me to fix that. Let's see. I think I can just share the entire screen too. And now when I open up the support options, there we go. Yeah. Okay. So so what I was showing, the crossbeam min height is this value, and when we increase that, then beams need to be taller before crossbeams will be drawn between them. And the crossbeam pullback is this value, and when I increased it to 5, now these crossbeams are much lower on the supports than they previously were, and you can see that the same thing has. Oops. You can see that the same thing has happened here, where these have been lowered quite a bit. The cylinder radius is how wide these cylinders are. When you're drawing really tall cylinders like this, having a wider cylinder radius makes them a little bit more rigid. So, so they'll have a little bit less wobble in them, but we haven't seen any problems drawing supports that tall. So generally we don't change it in-house. This insanely huge number is, if you want to not draw supports longer than a number, you can reduce this to something reasonable like 30. If I make this 30, then these long supports won't be drawn, but the short ones still will be. So that's there. Maybe there are situations where that's useful. Talk about max crossbeam length. So the minimum support length is useful if you don't lift a model up off the build plate. I think that there used to be a way to do that. I think that we've removed that option, or maybe it stopped functioning, so we removed it. The minimum support length is 3. Essentially turns. There is no minimum because the the object is raised 7 millimeters above the base. So the minimum support length, the minimum length is more than 3 already. So that's essentially turned off right now. So interior support lengths is another thing. So this being a value of 200 means it's essentially turned off. But if you want to draw, draw supports inside a model that go from this point down and touch the model itself, then that's the interior support length. You want to decrease this to, let's make it 1. And now when I support this, it should create a bunch of interior supports here. It will still draw critical supports, whether or not that that value is lowered. So these 2 supports will still draw even if that min interior support length is increased. But these ones are less important because they're just helping reduce strain. They're not absolutely critical to pick up a floating part. So if I change this back to 200, you should see that these 2 will remain and these ones will disappear, and possibly these 2 will remain as well. Yeah, so these two remain because they are critical supports and that they are holding up a floating part that would have appeared in midair had the supports not been there. But the rest of these are deemed uncritical, and so they're removed, or they're allowed to be removed by this min interior support length. The elevation you can change, but apparently must be higher than the base height, or else the model will dip into the base of supports. Support space. Oh, so this is the space between supports. If you increase this number to, say, 7, then you should see a lot fewer supports on the bottom. Well, let's make it 9 so that it's obvious. So there's a lot fewer supports now. There's even fewer critical supports. The space between critical supports in a line or area of critical regions is also increased when you change that number. This is how round the supports are. The touch point withdrawal was what we had a specific question about. And when you click it, you get this tooltip: the interior distance from model surface used to generate contact cone. So essentially what happens is, here you have the cone of the support. We should probably rename that to something a little bit more intuitive. But here you have the cone, and you can see that it would have come together about right here. The distance from here to here is that 0.8. So a contact, a touch point withdrawal of negative 0.8 means that the cone attempts to stick 0.8 millimeters into the model. So if you decrease that, then the area of the cone that touches the model is smaller. And if you increase that, or decrease it in absolute value, or increase it in absolute value to a more negative number, then you can have a bigger contact point between the cone and the model. So it's a way to alter how the size of the contact point. And if you make it too small, you risk the support not properly supporting the model. But it does have a smaller scar on the surface quality. If you make that number too big, you get bigger scars on the model, but you get but you have a stronger contact point, which can mean one support could hold up this whole floating chunk right here, say. Things like that. There are some advantages to having a larger contact point. This tree supports is what switches it to drawing trees instead of drawing individual columns as it's been doing now. So on this model, the trees, I think, look particularly cool. So here it's calculating. My laptop is streaming and running the software at the same time, and it's not a horribly powerful laptop, so it's getting bogged down a little bit. But you can see that these trees save a lot of material. This column is thicker, but it's not 9 times thicker, or however many. It looks like there are 7 supports. So this is not 7 times as thick, but it's one base holding up 7 supports. So it saves a decent amount of material using tree supports. So that's something that you'll have access to next software release, as well as some other support advancements. Like right now, we only try to draw supports downward or draw them directly to a tree. We're working on software that will automatically route supports around models, so that if the model sticks out, and it would, if this were trying to draw straight down, it gets awfully close to the model. So so the gap, oh, I've lost it. It's right here. The gap between this support and the model is awfully small, and so we have intelligent software that will draw the support angled outward a little bit to avoid intersection with the model. So that's another thing that we should probably have done before the next software release. And in general, with that, as well as the tree supports, the automatic support generation gets to be a lot better and a lot more reliable. And it's able to properly support more objects, and it wastes less resin as well. But it's still not perfect, and there will be times when, even after supporting it, if you run the model analysis software, you get you see that there's an unsupported floating part, and that happens. The model will try a bunch of different things to try to support an unsupported region. It will try to route around. It will try to connect to a tree trunk. It'll try to connect straight down. And if all of those things fail, it just won't draw anything, and it'll leave the section unsupported. So that can happen. And also sometimes the software is sort of doing its best attempt, and its best to make the model print. And its best attempt to make the model print involves a lot of support material, which means that a lot of this resin is probably unnecessary and somewhat wasteful. You could probably get away with half as many supports. So let me show you what sort of a minimal supporting of this model would look like. So right here, there's a part a section that's floating in midair. So we need to support that. And right here, this looks like it juts down a little bit, so that will need a support. And then at the bottom of this model here, this whole line needs a lot of supports. So maybe one every 5 millimeters or so. These grid lines are 10 millimeters or 1 centimeter apart. So if you put one every other grid line, then that's 5 millimeters of space between them, or 2 per grid line. Sorry. That one didn't place. So now that part is supported. If you were to print this model right now, it would probably fail and bend and rip off the supports as it's printing this angled part. So we're going to need some extra supports along the length of this curvy neck. So you just do a support every once in a while, and that will help a lot. Here we probably want an extra support here coming from this angle, very nearby on that face, and maybe one down here. And I would feel pretty confident that this would print as is. And the total resin used, this doesn't always update right now. This might be a little bit of an underestimate, but it's 8.8 millimeters instead of the 14 that we saw with tree supports, and I think it would be like 17 or 18 with the old style supports. So let's see. Let me make sure that I'm running the default parameters. This was 2.5. That's fine. That's good. Okay, so these look like the default parameters. So with tree supports, instead of 8.8 millimeters, we end up with, it'll be quite a bit more. I think it was like 14. 19.1. And if I switch to the old style supports, which I don't know if I should call them old style supports, because there are some models where column supports will be useful. Did I change that? So now it's the old style support. So instead of 19.1, we should get a number quite a bit larger. 22.9. So that's about a 25% savings when you use the tree supports instead of the column supports. And you can delete some of these columns and save yourself some resin that way as well, and use the automatic support less some. But the best way to save supports, but maybe it's a little bit dangerous to do. It increases your risk of build failure for sure. Is you can place your own and place them fairly sparsely. But if you get them too sparse, then there is some chance of a print failure. So that's why there's so many supports when you do automatic support placement. All right, let me glance back at the YouTube feed and see if there are any new questions to ask, and then I'll end this. It's been about an hour. Okay, I see one. I see one question in the Google groups from Master Shokin. He printed some earrings. They looked fine in retina, but they didn't come out. So he's asking about calibration issues with the I'm assuming laser calibration. We allow users to calibrate their own machines by using a 2D printer to print out a sheet of paper that you put in the vat, and you steer the laser to a bunch of points. It takes about 15 minutes for a person to do, so it's not that bad. It can take longer if you get really fine and you debate with yourself about how accurate each point is placed, but it's not that bad. Yeah, we do something different in-house, but it requires like specialized hardware that's sensing the laser and things like that. So you can't do that at home. But it doesn't seem to get more accurate calibration. It just allows a human to not be involved so that we can do it automatic. He's asking about the cost of the new vats, I think. So the what we're calling for now the super vats. Those should cost probably about $150, and they may ship standard with future printers. But to get a new one, I think we're looking at $150 to ship out. So it won't be terribly expensive. I don't think that's terribly expensive. Okay, let's see what the here's the questions up here. Getting an error. Something overflowing. Okay, so if you get any errors in the software, please let us know let support know or mention it in the forums. I look at the forums usually every day, every weekday at least. So when people post bugs, it really helps me find them, and so I need to if you can tell me what model you use and what orientation, and then I can figure out exactly what's going on. But from this information, it's not quite enough. You can save. I think that when you save a job, it saves all the settings. So so that's something you can definitely do. If you save the scene, it also, I believe, saves the settings so that when you load the scene, it will change the settings. That might be true only for some of the settings, and some of the settings are not saved. But I think that the settings are saved. But it would be nice. I think you're right that an export settings function would be useful, so that you can import and export settings and use them that way. Esteban is just agreeing with that. Print profiles and settings used. Yeah. So that's the end of my presentation. So thank you guys for watching. We'll post this online so that you can watch it again. Look at the details of anything you want to see again. If you have further questions, you can continue to ask them, and I'll try to pay attention. And also the forums, I'm always answering questions there. Thanks, guys. I hope you all like your prints and keep on printing. Bye.